First of all, I will start with the introduction by giving the definition of extreme temperature and how, when, where it will happen and the factor that contribute the extreme temperature. Extreme temperature can be defined by two events, which are the extreme heat and extreme cold. First, I will define the extreme heat. This is the temperature that are 10 degrees Celsius or greater than the region's normal high temperature and lasts for several weeks. Then another discomfort of this temperature, which is high, can be added by the humid condition when the damp air near the ground trapped by a dome of high atmosphere pressure. In addition, dust storm will be happen when in the condition of excessively hot and dry and also contribute low visibility. Furthermore, when a long period without enough rainfall, drought will be happen. And if it happen together with the heat wave, it will contribute a very dangerous situation that not as extreme heat hazard. So what is heat wave? It is the temperature of 35 degrees Celsius or higher, or it can also be the lower temperature accompanied by high level of humidity. Secondly, I will define the extreme cold. This is the temperature that are at or below freezing for an extended period of time, whereby the freezing point can be labeled as 0 degrees Celsius. Normally, this extreme cold outbreaks are part of the winter storm or cold snap events and occur at any time of the year. These events last for 3 days to 3 weeks, and with the temperature generally dropping below negative 15 degrees Celsius, so it can be said that it is really an extreme temperature that is a very cold temperature. Moreover, I will further present the extreme temperature and why it will happen. The extreme temperature will happen is based on some factors. First is the country's regions based on latitude and altitudes. In the mid-latitude regions, especially near the interior of a large continent, there will happen a winter minimum temperature will drop below negative 20 degrees Celsius and above 40 degrees Celsius for several weeks without the moderating influence of oceans. This normally will happen from June to August and December to February. This extreme low temperature can occur at any time between late fall or early spring in the polar regions and the high mid-latitudes, while the extreme high temperature from late spring through early fall are widespread in the lower mid-latitudes. In addition, the high altitude also subject to extreme low temperature and will occur for 9 months or more during the year in alpine regions, usually above 3,500 meters, dependent on the latitude. Secondly, another factor is the region based on what the population is accustomed to. Generally, the population which located at urbanized area will face the urban heat island effect. This effect normally occurs at overdeveloped areas which contribute the high temperature at daytime and remain so hot at nighttime. This is caused by the buildings, highways and open land and vegetation that are being replaced by another infrastructure because the surface are in dry and hot condition. So among of these changes, the urban areas will become warmer than the surrounding, that will cause the population will face severe heat waves. So it concludes that this urbanization will contribute to extreme temperature event. Thirdly, the climate change factor is one of the factors that will contribute to extreme temperature. This is due by the cumulative greenhouse gas emissions such as the carbon dioxide, carbon monoxide, and sulfur dioxide. Among of these climate change factors are the extended growing season, high temperatures, and the possibility of more intense, less frequent summer rainfall. By this factor, it can contribute to additional droughts and increased short-term droughts that caused by the extreme heat temperature.
Hello, my name is Chong Wei An. Now, I'm going to discuss about failures and defects of building due to extreme temperature. First and foremost, extreme heat may lead to cracks in reinforced concrete structures. Extreme high temperature affect the strength of concrete. It accelerates the hydration reaction within the concrete and increase rate of evaporation of moisture. Therefore, the strength and durability of the concrete are reduced due to the decrease of water-cement ratio. This situation leads to an increase in the tendency of differential thermal cracking. Secondly, steel structure will deform at extreme high temperatures. At high temperatures, steel will distort and deform. Failure to allow for these adjoints and changes of direction will cause buckling, distortion, and cracking. Decking and supporting materials which have different moisture or temperature movement coefficients will produce differential movement stresses at the interface. Therefore, it leads to force dimensional changes. Thirdly, timber construction may burn at extreme high temperatures. Fire may occur in wood buildings. The building burns with the wood adding fuel to the fire, will result in accelerating fire spread through the building. In the end, the fire will reduce the strength of the wood structure and its ability to support the building loads. Next, steel structure will corrode at extreme low temperatures. Steel will corrode in an environment with moisture and oxygen. The oxide formed from some metal ions take less space than the original metal. This produces a porous oxide layer which allows oxidation to continue into the body of the metal. Therefore, any holes in the coating or variable thickness will affect the durability locally. Besides that, timber gains high moisture content at extreme low temperatures. It will trap and elevate moisture content in buildings. This condition may result in timber decay. Timber decay may occur at roof timber, floor timber, and joinery timber such as door frame or window frame. Other than that, condensation may occur at extreme low temperatures and lead to failure of wall jointed. Initially, the structures lost heat due to low temperature in surrounding. Then, airspace in wet material is replaced with water. This happens when the inside of building becomes hot. Dampness can evaporate from interior surfaces, leaving behind hygroscopic salts. This can absorb moisture from the air within the building, which can add to the general dampness problem. In addition, the failure and defect also occur when both hot and cold temperature happening after one another. An example of the defect is roof thermal shock. The definition of thermal shock is that the temperature varies greatly from day to night during the day. As the temperature rises, the roof begins to expand. Then, when the temperature drops, the roof starts to shrink. Thermal expansion and contraction can damage the waterproof layer. This leads to crack and separation of seams, tearing of seams, separation of moisture, and deterioration of the entire roof. Lastly, there are three systems defects at different extreme temperatures. At extreme heat, electrical supply system may be affected. Cables get overheated when the temperature of the surrounding environment is high. This may trigger an electrical fire as well as cause malfunction of the electrical system. At extreme cold, building air conditioning systems may be affected. In winter, the interior of the building is more humid than the exterior. Hence, water vapor will tend to diffuse from the interior to exterior. The migrating moisture may reach a location in the wall where the insulation is at the dew point and condensation occurs. This condense water saturates insulation, rendering it useless as a heat loss barrier. If condensation levels are extreme, wooden structure members can deteriorate or steel ones can rust, compromising the structural integrity of a building. When both hot and cold temperature happening after one another, domestic water supply systems and wastewater systems are affected. There is large difference of temperature in day and night time. This difference brings expansion and contraction to piping systems. As a result, it will exert force and pressure on the piping system. The piping system may leak. In addition, all pipes placed in walls, roofs, and floors may corrode or rust. The head loss of the hot water supply system will increase. That's all from me. Thank you.
A very good day, IBETUR lecturer. My name is Moses Agan Molen, and I'm going to present on the application of civil engineering technology to overcome the problems due to extreme temperature. So, in the aspects of design technology, that is in extreme hot temperature, a design which is called green roof is used. The green roof of a building can be fully or part covered with a layer of vegetation which is known as green roof. A green roof is a layered system comprising of a waterproofing membrane, a growing medium, and the vegetation layer itself. A green roof offers a building and its surrounding environment many benefits. This includes stormwater management, improved water runoff quality, improved urban air quality, extension of roof life, and a reduction of the urban heat island effect. Meanwhile, in extreme cold temperature, design which is called the narrow passage design are used. This design of narrow passage takes more advantage from heat and prevent cold and heat exchange. In this type of region, the residential areas are usually established in the middle of height slope towards the south and in or on the ground to enhance the heat capacity of northern walls and increase the interior volume in relation to exterior surface. Next is in the aspects of construction technology. In extreme hot temperature, mechanical expansion joints are used to accommodate regular thermal contraction and expansion of building materials during seasonal variation. It helps absorb the natural thermal contraction and expansion of building materials that occurs over time and mitigate the risk of structural deterioration and cracking in concrete. Meanwhile, in extreme cold temperature, materials with good thermal capacity are used to keep the building warm in its inner area and prevent moisture. So the body of these buildings is from stone, wood, mortar, adobe and bricks, and the roofing is basically from timber and cork. Next is the expectation to overcome the problems which is due to extreme temperature in the future. Now the first that we can expect is using the Bauhaus German design. Buildings in Tel Aviv also benefited from this Bauhaus German design, uh, which is benefited from the Bauhaus School of Architecture and Design. The Bauhaus penchant for flat roofs, for example, has proven to be useful as they will reflect solar heat. With new technologies such as advent of solar panels emerging from time, flat roofs have continued to be popular in hot urban centers. Next is using the chill design. The architect addressed the tropical climate by creating spaces for open gardens and courtyards for the wind to move. Classrooms, he said, are always 7 degrees Celsius cooler than the outside temperature. Next is using the ancient design. The street temperature in Abu Dhabi's Masdar City neighborhood is up to 20 degrees Celsius cooler than the heat in the surrounding desert, as a wind tower channels cooler air from the sky and pushes it down to form a cooling breeze, which is copied from the ancient city of Muscat, Oman. And next is using a passive building design. Passive building design incorporates features that minimize the impact on the environment, which is, for example, of smaller windows, overhang roofs, spaces for solar panels or rooftop gardens where the rain can cool off the building while feeding the plants that offset the carbon emissions. That's all from my part. Thank you.
So hi, my name is Albert Lim. So right now I'm going to present about the issue, which is the issue in Malaysia and the issue in other country, which is Denmark. So in Malaysia, as we know, Malaysia has heavy rainfall and warm sunshine all year round. So extreme weather condition is one of the factor that affecting the construction. So if the prevention is not done, the extremely hot condition will not only affect the workmanship but also will cause crack line to the wall that facing the sunlight under the high temperature. So let's move to Denmark. So in Denmark, we can relate in particular to the limitation of snow and storm damage. With regard to the reinforcement of existing building, autonomous adaptation will be limited if the owner are not aware of the weaknesses in the bearing element of the building. So if the prevention procedure is not considered, there will be no change to the legislation on the building safety under extreme weather condition. So for the conclusion, structural defect in a building can occur over time due to climate change, which is, for the example, extreme temperature. So the application to overcome this situation is, for the example, in extreme heat, the expansion joint can help absorb the natural thermal contraction and expansion of the building material, while in extreme cold place, the material selection can follow the material used in traditional buildings in cold and mountainous region. So in future, existing building may need to be informed of the typical weaknesses of the bearing element, which with instruction for their remediation. In the same way, instruction on new construction solution may also be required, particularly for vulnerable building to reduce indoor temperature during extreme heat wave. So finally, there might be a need to notify construction technician of recommended future-oriented design parameters, for example, concerning maximum snow load and wind speed, temperature and duration of future heat wave, and the maximum precipitation intensity a building can withstand. So that's all from me, and thank you